In this example, we will solve a one-variable, multi-step linear inequality. Here we have our original equation, and we can see that on both sides of the inequality symbol, we need to distribute. We'll start by distributing the 5 into the first set of parentheses, and then independently, on the other side of the inequality symbol, we'll distribute the -3 to the second set of parentheses. Then we see that there are two constant terms on the right-hand side of the inequality symbol that need to be combined. And when we do that, 9 plus 18 combines to 27 on the right-hand side of the inequality. Next, we need to collect the variable terms on one side of the inequality. For this one, I'm going to add 3 into both sides. Then we want to move the constant terms to the opposite side of the inequality, and for this situation I will subtract 30 from both sides. Finally, we need to isolate the variable n, so we will divide by -2 on both sides. Because we divided by a negative on both sides, we need to flip the inequality symbol. So our final answer is n is less than 1.5. Let's take a look at what this solution looks like on a number line. We're going to choose values to the right and left of 1.5 on a number line. I'm going to choose 1 because that's smaller than 1.5 and 2 because that's larger. Then we see that n is less than, which we know will be an open dot, and less than goes to the left on a number line. So we'll position this on our number line. And we want to test and see if the given points are included in our solution set of n is less than 1.5. So we can use that expression, substitute in the value for n, and see if that statement is true or false to verify algebraically. So if I substitute 0 for n in our expression for our solution, we see that 0 is less than 1.5. That is a true statement, so 0 is contained in the solution set. If we check out the number line, 0 would be over here to the left, which is contained in the solution set indicated by the arrow. Next we have n equals 1.5. We'll substitute 1.5 into the n is less than 1.5 expression for our solution, but this is a false statement. 1.5 is equal to 1.5, but it is not less than. So n equals 1.5 is not contained in the solution set, which we can see on the number line with the open dot. That means it gets really close to the value 1.5, but it actually has to be just slightly less than that to start being contained in the solution set. 1.5 itself is not contained in the solution set. And last, we will test point n equals 2. 2 is less than 1.5. This is a false statement, so n equals 2 is also not in the solution set, which we can see on the number line. We actually chose 2 here as one of our points, but we know it's to the right of 1.5 on a number line, and it is not contained in our solution set.